Good morning, sir. Today I am going to present on Rachman's classification system. I referred the guidelines for Rachman's classification system, which was issued by Japan International Cooperation Agency in February 2018. Introduction to Rachman's classification. Rachman's classification schemes used to be to build the picture of composition and characteristics of rock mass and to provide initial estimates of support requirements and to provide estimates of the strength and deformation properties of the rock mass. However, it is also useful to design procedure requires access to relatively detailed information on in-situ stresses on rock mass properties and planned excavation sequence. Engineering rock mass classification. Terjagi's descriptions. Intact rock contains neither joints nor hair cracks. If the injury to the rock due to the blasting, spalls may drop off the roof several hours or days after blasting. This is known as spalling conditions. Stratified rock, stratified rock contains a no resistance against separation along the boundaries between the strata. Moderately jointed rock contains joint and hair cracks. Blacky and seam rock consists of chemically intact or almost intact rock fragments which are entirely separated from each other. Crushed but chemically intact rock has all of the fragments are as small as fine and grains. No recementation has taken place. Squeezing rock slowly advances into the tunnel without a perceptible volume increases. Swelling rock advances into the tunnel chiefly on account of expansion. Rock quality designation index. It is defined as a percentage of intact core pieces longer than 100 mm in the total length of a core. This is the formula. If the RQD percentage is less than 25%, the rock quality is very poor. If it is 25 to 50%, it is the rock quality is poor. If the RQD percentage is 50 to 75%, the rock quality is fair. The RQD percentage is 75 to 90, then the rock quality is good. The rock quality, if RQD is 90 to 100%, the rock quality is very good. Geomechanics classifications. It is also known as rock massing rating system. It consists 6 parameters which are used to classify rock mass using the RMR system. The first one is uniaxial compressive strength of rock material. Second one is rock quality designation index. Third one is spacing of discontinuities. Fourth one is condition of discontinuities. Fifth one is groundwater condition, and the last one is orientation of discontinuities. The overall rating of the systems are given as the sum of parameters plus discontinuity orientation of adjustment. These are the parameters: strength of intact material, that is the point load strength index and the uniaxial compressive strength index. If point load strength index greater than 10 and the uniaxial compressive strength is greater than 250 megapascals, then the rating is given as 15. And similarly, this is the strength of a point load strength index and the uniaxial compressive strength index, and this is the rating given accordingly to the compressive strength and point load strength index. If drill core quality, if it is 90 to 100%, then the rating is given as 20. If it is 75 to 90, then the rating is given as 17. If it is 50 to 75, then the rating is given as 13. If it is 75 to 50, then the rating is given as 8. And the core quality is less than 25%, then the rating is given as 3. Spacing of discontinuities, and according to their ratings, and this is fourth one is condition of discontinuities, uh, their ratings, groundwater and their ratings. And these are the guidelines for classification of a discontinuity condition and effect of discontinuity strike on dip orientation and tunneling. Uh, according, uh, according to the dip, these are considered as very favorable or fair and so on. Rock tunneling quality index. Rock tunneling quality index. The formula for this is RQD by JN multiplied by JR by JA multiplied by JW by SRF. Here, where Jn is the joint set number, Jr is the joint roughness number, Ja is the joint alteration number, Jw is the joint water reduction factor, SRF is the stress reduction factor. Classification of individual parameters used in the tunneling quality index. If RQD is 0 to 25, then it is very poor. If the RQD is 50 to 75, then it is fair. If RQD is 90 to 100, then it is excellent. When the RQD is reported as less than or equal to 10, a nominal value of 10 is used as a equivalent Q, a joint set number Jn. If the joint set number is zero point 0.5 to 1, then the then it is massive or no few joints. Joint reference number Jr. If, add 1 if the mean spacing of the relevant joint set is greater than 3 meter. Jr equal to zero point 0.5 can be used for planar sliken-sided joints having lineation. These are the joint roughness number given according to their joints. Joint alteration number. Joint values of joint alteration number, the residual friction angle, are intended as an approximate guide to the mineralogical properties of the alteration products if present. These are the joint alteration numbers. These are joint alteration numbers. Joint water reduction, joint water reduction factor. If dry excavation or minor inflow, then joint water reduction is 1. Medium inflow or pressure occasional outwash of joint flanks, then it is 0.66. Exceptionally high inflow or pressure, then it is 0.1 to 0.06. Stress reduction factors. Multiple occurrences of weakness zones containing day or chemically disintegrated rock, very loose surrounding rock at any depth, then the stress reduction factor is given as 10. Loose opening joints, heavily joints or sugar cube at any depth, then the stress reduction factor is given as 5. Reduce these values of stress reduction factors by 25 to 50%, but only if the relevant shear zones influence do not intersect the excavation. These are the stress reduction factor for competent rock or rock stress problems. These are stress reduction for squeezing rock, plastic flow of incompetent rock under influence or high rock pressure. Conclusion. The classification system consists of the following steps: determination of mechanical parameters of rock mass and transformation of rock mechanical properties into the rock mass parameters. Parameters shall be studied and optimized by choosing other different systems. A setup of a numerical model on the basis of real geological situations and perform simulation by using the model and mechanical parameters. Compared to other methods such as empirical correlations or simple analytical calculations, numerical modeling offers a much more detailed and physically based insight into the interaction between the rock mass and tunnel supports. These are my references. Guidelines for rock mass classification system Road Development Authority, Japan International Cooperation Agency. 2018 is a recent journal. Thank you.